Hey guys, welcome to another video about Unity. And today I'm going to show you how I create this beautiful clouds effect in Unity URP. This video will cover some basic shader knowledge, so I hope you have some understanding before watching this. Okay, now let's get started. So if you've ever searched for how to make clouds in Unity on YouTube, you may find this video created by Sebastian Lague. This video explains many of the technical aspects and the implementation process behind the cloud effect. If you want to learn more about this effect, I recommend watching the original video. I will put the link in the description. The reason I mentioned this video is because it provides a GitHub link where we can view the source code, so we can download it and apply it to our project. Open the link and then you will see this page. Click on the asset folder and let's find some files we need. In the resource folder, you will see many files ending with asset. There are 3D textures. You can download them first because we will need them later. And in the script folder, we can find the script controlling the effect and the shader for the clouds. This cloud master script is the control script we need. Let's take a look at its code. And here on render image is used. As far as I know, on render image doesn't work in URP, which means this is for a default pipeline. So we need to find another way to replace it to make this effect work in URP. Luckily in URP there's a function called renderer feature. It allows us to use shaders to edit the game visuals, just like what onRenderImage does. So we can use it to replace onRenderImage function. To set up a renderer feature, we first need a script to achieve this effect. I have prepared a simple script already. You can use and download it via my GitHub. I will also put the link in the description. Click here to download this script file, and then put it in your project folder. Next, go to the settings folder. It should be located inside the asset folder. Then click on the camera object in your scene. You can find the renderer you're currently using in the camera object's rendering settings. The one I'm using is called the forward renderer. Select the asset with the same name in the settings folder, then click on Add Renderer feature. The script I created is named Effect, so let's find it in the options. After adding it, the settings control panel will appear here, and it will require us to assign a material to it. So let's create one to use. Right-click on your folder, and select Shader, then Unlit Shader, and give it a name you like. After completing creating the shader, right-click on the shader file to create a material. In the Effect Control panel, we assign the material we just created. Using the search function can help us quickly find it. After selecting, nothing happens here, because we haven't edited the shader file yet. So double-click on the shader file to open the Visual Studio code. After opening the file, you will see that Unity has already written most of the code for us. But there is some code that we won't need. Like this code about fog, we won't be using it, so let's delete it for now. After deleting them, we can start to editing this file. At the bottom of the code, here is the part where the final color output is. Let's modify the code and test if the renderer feature is working properly. Change the return result to be 1 minus the color to see what will happen. Okay, now we have a negative effect filter in our scene. This means the renderer feature is working fine. Next, let's create this black box, which represents the area where the clouds will be rendered. First, we need to get the world position of the camera in the scene, and as well as its facing direction. We can obtain the camera position using the built-in shader variables. For the direction the camera is facing, we need to do some calculations. Add a float 3 in the v2f structure to store the direction. Then at line 44, we transform the UV coordinates from the 0-1 range to the -1-1 range, and multiplies them by the inverse projection matrix to get the view vector. Then transforms the view vector from view space to world space using the camera to world matrix. Next, we need a depth texture to prevent clouds from covering objects in front of them. To use a depth texture, we must declare the sampler to D for the depth texture here. otherwise Unity won't be able to find it. And then we will use this box distance function to get the distance between the camera and the box. To calculate where the box should be rendered, we need two vectors to represent the max and min positions of the box. Finally, we turn the pixels inside the box to 0, which is black, so we can see where it is. So we've finished modifying this box shader. Let's save it and see how it looks in Unity. And yeah, nothing happened here. That is because we forgot an important step. We should control the material values through this settings panel here. Since we haven't set any vectors, the size of the box is 0 now. So let's add some variables in the render feature script and make them display in the settings panel. First, we need two vectors to control the box range, just like in the shader. It's best to name them the same as in the shader to avoid forgetting later on. Then scroll down to the execute function here. We need to pass the values on the panel to our material, and we can do this using the setVector function. Put the shader variable name first, then the variable name from the script. After saving, return to Unity, and now we can see the black area in the scene. This means our script has successfully passed the values to the material. And we can control the size of this range through this settings panel. After completing the above parts, we can start creating the shape of the clouds. Make our clouds more than just black box. To create the shape of the clouds, we can calculate it using textures. Using the sample density can help us calculate whether the current pixel is inside the cloud shape or not. Here, we use a while loop to repeatedly sample, until the sampling point is outside the rendering range. And eventually we will get a value representing the cloud's transmits. In the sample density function, we'll be using several variables, so we need to declare them first. Place the variables to be declared here. These are the variables we'll be using for now. Also, don't forget to add these variables in the render of future script, so we can control them from the settings panel. Then remember to pass the values from the settings to our material. Now we can input a texture to control the shape of the clouds. The texture I'm using looks like this. It is a simple cloud noise texture. You can search for tutorials on how to create this type of texture, or find one online that you're satisfied with. If everything goes as planned when you return to the scene, you'll be able to see those dark clouds in the sky. We can change the file output color value to a color variable, so we can control the color of the clouds. Currently, our clouds are only using one texture, which looks a bit plain, so we can blend two textures to create a better cloud shape. And remember to add the corresponding variables in the script. Now, when we return to Unity, there will be additional settings for the detailed cloud in the settings panel. It requires assign a 3D texture. We can use the 3D textures we just downloaded earlier. And I've created a slider that can control the blend ratio of the two textures. Our cloud shader is nearly finished. However, what's currently missing, and most importantly, is shadows. Shadows are essential to give our clouds a realistic appearance, rather than just some flat images. To achieve shadow effects, we can check how Sebastian Lague did it on his GitHub. You can find this cloud shader in the shaders folder, and you can also use this shader to replace the one you created, if you know how to modify it. And here, those lines of code, they are controlling the final color output, including the shadow effect. We can copy them and then replace our original shader code with them. Let's save it and see if there are any error messages. As expected, such a simple copy and paste will lead to many errors. So our next task is to correct each error based on the information provided in the error messages, such as missing variables or functions. We just need to find the matching code to fix these errors. Once corrected, our shader will work properly. So, after spending some time on it, this is how my code currently looks like. I will put the modified shader and script on GitHub. You can find the link in the description. Lastly, I should mention that this shader isn't highly optimized for now. If you plan to use it in your game, it might affect the game performance. So I'd suggest you looking up some optimization tips online for this code. Anyway, this is the end of the video. If you found it helpful, please leave a like or leave a comment. And thank you for watching. See you in another video.